recording also. Still they are like just 39. There should be 48 students here, so I'm just waiting for them. Okay, so I hope everyone is here. I guess there are now 44 students. Rather than there should be 48, 2 or 3 of them will be joining over here. Please remember the attendance in this session is important because we should be knowing that you are actually were present and you had the idea what we were discussing. If you have any questions during this over here, you can write down in the conversation window and I will be going there and seeing them. Okay, so if I go back to what we are going to do in these projects over here, the first word, very simple. They are just extensions of what you have done already in your lab up till now. You have done yellow dot matrix, you have done the RGB dot matrix over here. So this one, these 6 projects over here, as you can see over here, from project number 2, serial number 2 to project number 7. I'm not going to go through each one of them, but the point which is important in all of these ones is this, that you are not having just one matrix over here, or one matrix display is not just that. You are having like 4 or maybe 6, and I guess 6 are not there anywhere, so the maximum one is 4. So each one of them has 4 actually, so 2 cross 2. Now what does 2 cross 2 means? Now this is very important. Please see this one. I'm drawing this diagram over here in front of you. So when I'm using the word 2 cross 2, what does 2 cross 2 means? Sorry, this has just changed over here. Don't worry, it's not stuck actually. Actually, I'm using my mobile as a. Don't worry, I know the video is stuck. Actually, I moved my cable, so that's why. Nothing happened, don't worry. Everything is being recorded. I hope now you can see this screen over here. Okay. Yes, beta, recording has started, so don't worry on that part. So. Okay, now I hope everyone can see this screen over here, which I have shared just now. Again, actually the problem was that the wire actually went. So I hope everyone is having a look at this one. So this is the same project number 2 to 7 project over there. This one. Now, what does 2 cross 2 means over here? This is very important. Now 2 cross 2, when I'm using the word 2 cross 2, 2 cross 2 means that if I have this one, supposedly, I have, since I'm talking about the green color dot matrix over here, so what this means actually that I have one dot matrix here, and I have one dot matrix. Now the reason I am putting some space over here is not that you have to actually physically make this space. I'm just showing it over here because these are like 4 different matrices over here. So this is the third one, and this is the fourth one. So 2 cross 2 means that they are actually 2 in the rows and 2 in the column. So just like you define a matrix in mathematics over here, so rows into column. So similarly, you can call it, this is the first column, this is the second column, and similarly this is the first row and this is the second column. Anyway, now one thing very important, we will talk about this yellow or green or whatever you are going to do on this one just little later. Now when you have this as a dot matrix, and since you all know they will be like 1 2 3 4 5 6 7 8 over here, and similarly 8 over here, and the same replica in all of these 4 over here. So what this means actually is this, that here they will be, if it's a 2 cross 2, then you will be having 8 here, 8 here, and if they are arranged in row wise or column wise, that depends upon which dot matrix you are going to use. If it's going to be yellow, then it's going to be different. If it's going to be green, it's going to be different, and if it is RGB, it's going to be different. Yes, but it is being recorded, don't worry, this is being recorded, everything is being recorded, it is over there. So what this means over here, supposingly this is a yellow one, this is also yellow, this is also yellow, this is also yellow. Now you are fully aware that in yellow dot matrix, if I open the yellow dot matrix data sheet in front of you, let me just open that in front of you. Some students are coming late, beta, please be here anytime. Okay, I hope everyone can see this. I have now shared my whole screen actually instead of just one. Now, for those since all of you have already worked on this green or yellow color dot circuitry over there, so if you are going to talk about this one, yellow dot matrix. Now, if this yellow dot matrix which is in front of you, let me just open it up in front of you. The yellow dot matrix over here has this arranged in such a way that the columns are going to be energized. Okay, I hope everyone can see this one now, that column 1, column 2, 3, 4, 5, 6, 7, 8, which means that you are going to energize from this column, you are going to energize from this column, 3rd, 4th, 5th, 6th, 7th, 8th. Then this will be the 9th, 10, 11, 12, 13, 14, 15, 16. So these are the columns by which you are energizing all what is available over here in this one. So this is from 1 to 8 over here, and this is from 9 to 16 over here. So what you are doing over here, that you are having columns energized over here. So when you are having this energization over there, now when you are arranged it into 2 cross 2, this means that they will be also having some columns over here which will be actually also energized. So when you are going to connect this one with the transistor over there, and that transistor over here will be certainly this one, 2SA684 over here. It is actually the Dept package, but here you use BC869, that is actually the SMD package. So when you are going to connect that transistor over here with this first column, that same wire is also going to come and connect with this one, because it's the same column actually. So when you are energizing it, if it's a yellow dot matrix, we'll come back to the green as well just a little later. So the first transistor is going to be connected with this one, and it's also going to be connected with this one. So what this will do, since this is column number 1 over here, so all the column is going to be energized over here. So this is, and similarly you will repeat it for the 16 columns over here that are available. So what this means actually, that when you are going to have the 16 columns over here, so this means there will be 16 transistor circuitries over here for 2 cross 2. Okay, I'm just talking about 2 cross 2 at present. Now there are some projects over here which are 1 cross 4. Now 1 cross 4 means, since 1 is the row and 4 means the column. So in that case, when you are going to have 1 cross 4, and certainly that is RGB supposedly, let's use another color over here for this one. So this will be something, this will be the first, this will be the second, this will be the third, and this will be the fourth one. So in this way you are going to arrange these one. Now this is actually something horizontal, so you are going to have the circuitry like this over here. So if it's going to be RGB, then certainly you are going to go towards more towards the RGB circuitry. So supposedly if I want to talk about the RGB circuit diagram, so let me just open that one also in front of you, that for RGB circuitry, if you see the data sheet over there, if you see the data sheet over here, let me just open it. It is arranged as row. Okay, RGB arranged as row over here, which means that this is row number 1 over here, this is row number 2, row number let me just open that one. This is 1, this is 2, this is 1, this is 2, this is 3, then 4, then 5, then 6, and 7, and then 8. So here in this way you are having 8 rows. Now since they are arranged in rows over there, you are going to connect this one also with one, this second dot matrix with this one, then third with this one, and similarly all of these are going to be connected row wise with all the same transistors over there, just like you have done this one for a 2 cross 2 yellow dot matrix, because that was arranged as column wise. If it is RGB, then it has to be arranged as row wise. This is from the transistor point of view. So here in this 1 cross 4, this is the first dot matrix, this is the second one, this is the third one, and this is the fourth one. And for this one, you only require 8 transistors over there. Now when I'm using the word transistors, this does not mean that I am referring to only one transistor. One transistor here circuitry means that it's actually made up of this 2 and 3904, which is actually in SMD1A, and 2SS684, which is in BC869 in SMD. So this pair, this transistor pair over here, these are going to be used 8 of them in this 1 cross 4, and if you have something 2 cross 2, then it is going to be arranged and it's going to be 16 of them, because here it is column wise giving power over here. So this is from the side which is actually called as the driver side. So all of these projects where you are talking about 1 cross 1, 1 cross 4, or 2 cross 2, 2 cross 2, here this is 1 cross 4, all of these have approximately if it is something yellow or green, then it is going to be 16 transistors. But if it is something RGB, as you can see this project 1 cross 4 RGB, here you can see over here this is having only 8 transistors over here. So 8 transistor pairs over here. Now coming on to the other side, that is actually where you are actually going to sink the current, by which I mean that G beta, any questions? If you have written down. Beta, this is being recorded. I don't know, beta, the voice is, it should be clear from yours. Must be some internet problem at your end. Don't worry, I will upload this one on the YouTube channel again. Okay, so this is being recorded. So whatever I am speaking is being recorded, so you will get it. Hopefully this will be small file, so it will not take much time to record on this one. Okay, now if you have seen this yellow one, okay, don't worry, beta. If you have seen this yellow one over there, they are arranged column wise, and then you have to connect these rows over here with UN. It will have row wise ULN 2803 over there. So when you have arranged something that is like this over here, if I have used this one, where has the circuitry gone? Okay, this is that circuit. Now when you have powered it with the row 1, no beta, the question which you are saying is wrong actually at present. So I will come back to it. I will come back to the question a little later. Okay. In fact, let me just turn this off. Okay. So when these are column arranged over there, so if it is going to be the first row of this one, so when I have this one, supposedly I am using this red color over here. So when I am using this one over here, it's not working over here. know why this is, but we just added it again. Wait a tad second. This is actually gone a little above here. Okay, now this is working. Okay, I hope everyone can have a look at this one now. Okay, now when I will answer the question, just let me complete this one. So this is column wise over here. Now when you are talking about the row wise, so when you are going to connect the first row, this is going to be connected with the first row of this dot matrix, second row connected with the second row of this matrix, third row connected with the dot matrix, this matrix, fourth like this, and so on for 8 one. But here this time they are not just 8 rows, there are 8 more of them in this dot matrix. So this time you are not just going to have one ULN 2803, you are going to have two ULN 2803, because here this time you have, this is 8 over here and you have 8 over here. So one ULN 2803 will be here, one ULN 2803 would be here. So you will require for 4 this 2 cross 2 dot matrix connection, either it is yellow or green, not for RGB. RGB it will be different. Then go here, this will be ULN 2803 IC here, ULN 2803 IC here in this case. Now, coming on to the questions that you have asked over there, because these are very important questions. Okay, Ahmad Asim, you have asked, so basically we have to use total 4 transistors for column 1 of 4. No beta, I have not asked, told this one. I have told you repeatedly that over here, if you are having a 2 cross 2 yellow or green dot matrix, then yellow dot matrix, it is arranged as column wise over here. So there are 8 columns over here in one dot matrix, but when you are arranging them in 2 cross 2, so there are 8 columns here, 8 columns here, so there are 16 columns. So what you will require, you will require 16 of these transistors over here. Transistor pair, let me use the word transistor pair. So there will be 16 of the transistors pair over there. Okay. Okay, so Ammar Akhtar has asked over here, sir, 1 into 4 dot matrix को transistors beta, when you are having 1 into 4 over there, when you have into 1 into 4 over there, 1 into 4 means that they are arranged something like this. So if you are having 1 into 4 supposedly, and it is green supposedly, and I will share you what the green as well. This is 1, 2, 3 and this is 4. Now if you want to find out the green dot matrix is a little different over there. Now if you see this green dot matrix, please see this one very carefully, which I am showing at present in the screen. This is arranged row wise. Okay, so you are lucky over here that this is arranged row wise. So the power connection has to begin at pin number 7, 9, 5, 11, 3, 13, 1 and 15. So this means that you are going to have 1, 2, 3, 4, 5, 6, 7, 8. So 8 transistor pairs are going to be there for the first, this is the first dot matrix, and with the second dot matrix the same will flow. So 1 cross 4 green dot matrix, you are going to have only 8 transistor pairs over here, and they will be connected with all of these over here. But one thing important, when you are going to have ULN 2803 IC, you will have 4 of these ULN ICs over here, because each one of them has 8 bits data, and here you have approximately, this is the 4 dot matrix over there. So you are having 8 over here. So column wise there will be 8 connections here, column wise connections here, column wise connection here, column wise connection here. So if you are not using 75 SC595, this one they will be male headers over here, and these male headers will be 8 here, 8 pin here, 8 pin here, 8 pin here. So this means 8432 pins header will be here, and when you are using the transistors over here at this point over there, so here this will be 8 pins also here. Okay, so this is for 1 cross 4 green dot matrix, and those who are using 1 cross 4 green dot matrix, 1 cross green dot color matrix, that will be used with sorry, this is a problem over here. You can change this one over here. This is not ULN 200, this is ULN 2803, and this has to be used with 74SC595. Now what is 7SC595, how it works, that Sir Bilal will actually tell to you about it, and we will share some help links also. What is the usage? Here you have 8 pins here. Let me use the other one. Here you have 8 pins here. 8 pins here. Sorry about this. This is, I don't know why it gets stuck every time. Let me. Okay, so you have 8 pins over here. Sorry about this delay again. Actually, the mobile actually let me just turn off my Wi-Fi at my mobile, because I'm getting again and again messages over here. Okay, now for those who are having 74SC595, what you have to do, since these are 8 bits here, 8 bits here, 8 bits here, 8 bit here, you have to give this data to from a microcontroller. Now to get a microcontroller which has approximately 32 pins is very difficult. Okay, because it is going to be very consuming on the microcontroller side. 32 pins microcontroller will also be large. So what does 75HC595? It's a small IC that is actually I'm just going to write 595 here, and what this IC will do, we are going to connect 4 of these ICs over here, and we are going to connect in such a way that it will take serial data in, which means serially, just like your hard disk or USB, how does it take data on one wire? It's going to take data in. From here the data will come out and it will go in the next IC, and from here it will come out and again go in the next IC. From here it will come out and go in the next IC. And these ICs are going to take in serial data, and they are going to give 8 bits output here, 8 bits output here, 8 bits output here, 8 bits output here. So in this way, just by the use of one serial pin from the microcontroller and certainly some clock over here and some associated pins which Sir Bilal will actually deal with you, you are going to have this 595 IC from one pin controlled from the microcontroller. You are going to have just 7SC595 giving you 8 bits. Now this is used where you want to actually convert the 8-bit parallel data into serial. This is parallel data. Here you are getting 8 bits here, 8 bits here, 8 bits here, 8 bits here, but you don't have enough pins on your microcontroller or the interface device. Then you are going to have a serial pin over here, and that serial pin with some control pin, certainly that is going to be. Now we are not going to ask you to code this and all that. That code will be supplied by me and by Sir Bilal, so we are going to do it yourself. The only thing that you have to do is just to place this IC, connect with these 8 pins over here with the input pins of ULN 2803 IC over here, which are here, and then the rest of the connection over here. So all those projects which have that 75HC595, they are just going to take in serial data. Certainly there will be some mail header over there from where the serial data will actually go in, and then you are going to take 8-bit data out from each one of them. Now this was 32 pins over there. For example, there is a project over here that is 2x2, that is green color dot matrix. Now if I go back over here and if I change this supposedly for those who are having this green over here, now 2x2 means that I have this green color dot matrix here, and I have another here, and I have another here. Now green color dot matrix is arranged row wise. Okay, it is arranged row wise. So this means that the first transistor pair will be here, and this will be connected with this one. Second transistor pair will be connected with the second row, which is actually pin number 9 over here, which you are seeing over here, and then it will be connected with this dot matrix. Third one similarly, 8 over here, this one, and then from 9 up till the 16th one connected over here like this. So there will be 16 pairs over here, transistor pairs, and when you will come on towards the ULN2803 side, there are 1 2 3 4 5 6 7 8 columns. So this means there will be 8 columns over here, 8 columns over here, so 8 columns, and these columns will be combined with this upper one, this will be combined with other one. So you are going to have one ULN2803 IC over here that will be connected over here, and this ULN2803 IC will be connected with another IC that is 75HC595 over here, similarly 595, and here you are going to give serial data in over here like this one, and this is that ULN IC, this is that ULN IC, and from this out data this will be going into serial, and from here 8 bits data will be available out over here. So just by one serial pin, some clock pins, this is the clock pin, this is the serial data in. So you are going to have this 4x4 dot matrix run by having, certainly male header will be required for this 16 of these one over here, but here just for 75HC595 you will only require just maybe 2 or 3 pins. One is the serial data in, another one is the clock over here. Now for those who are talking about, I will come to questions afterwards, don't worry, we will have an extended session for that one, still we have time over there. Now if you go on this one, those who are having RGB dot matrix, okay, now they are they will have a little complex PCB over here. Those ones, I guess there are 3 PCBs, 3 projects over here, 2x2, 2x2 and 1x4. Now what does 2x2 means RGB? This is very important. Again you are going to arrange, let me use another color just for it. So if you have, this is 1, this is 2 RGB, and here you have third, and here you have the fourth. Now in RGB dot matrix, if you have seen the data sheet over there, let me just open that RGB data sheet, everything is row wise. So here the first row is going to be, this is the first row connected with the first row over here, second row connected with the second of this one also, similarly 8 here connected with over here, and 9 here connected over here. So this is actually the first row of this dot matrix, and 16 here that will be connected over here. Now so this means there will be 16 transistor pairs, and since now when you are going to connect it with this, now on the column side you have 3 different, because there is R, there is green, the red, green and blue. So now when you have 3 over there, now this will actually become a difficult one over here, and to make it concise, this is actually going to be the task that is going to be with you. Now when these are row arranged, you will take, first of all, that is the red color over there, you will take the red 8 pins coming on from here and connect this one with a ULN2803 IC. Similarly you will connect another ULN2803 IC, connect that 8 one, and certainly not to mention that this one will be connected with this one red as well, which is actually the column over here. So you are going to have ULN2803 connected, this is the red ULN2803. Okay, this will be connected with this dot matrix, with this dot matrix column wise, and this will be connected with the above dot matrix also. Now when this is done, the next thing would be that you have to actually attach a green colored ULN2803. For that green colored ULN2803, you will attach some new ULN2803. So this will mean that you will have 2 more ULN2803, and they will be connected with the columns over here. Similarly, you will have the blue ULN2803. So this will be blue ULN connected, and that will be connected again with the same one. So this time for 2 cross 2, you will be having 6 ULN2803. This is, and certainly one thing very important, when they are going to be connected with column, you will certainly have a resistor in between. That resistor SMD in 1210 packaging, do not miss it. This is very important over there. Okay, so those projects, those who are, if I go back on the project list over here, those projects, let me just firstly on that one. So those who are having this RGB dot matrix here, this is just ULN2803 and transistors over here embedded. That's all. Then there is 2 into 2 RGB dot matrix with ULN2803A and also using 74SC595. Now here, these two projects, this one, there's 2 cross 2 and 1 cross 4. You are using 74SC595. This is actually 595 over here. So let me try not use that over here. There is my. So here, when you are going to have, you are going to connect it 75SC95 over here at this point also, this point also, this point also, this point. So there will be another IC over here which will be 595. There will be another IC 595. There will be another IC 595. There will be another IC 595. So here, those who are going to have 595 IC available, here again 6 595 ICs will be there, and certainly for the red one you will have serial data in, for this one green one you will have another serial data in. So here this time there will be 3 serial data in, and certainly they will be connected with the other ones over there. So these two projects, which are the last two projects, which is serial number 6 and 7, they will be a little difficult from the complexity point of view. They will be a little difficult from the complexity point of view. Otherwise, they are still doable. Okay, coming on to quasi. Look at this one. I am okay. I will just go through it again. Don't worry. It is recorded, but I will still go through it. I hope everyone is having a look what I am showing at present over here. Now, if you see over here, this was 1 cross 4 dot matrix over here. This was 1 cross 4 dot matrix, and I told you if this is yellow or green, that is totally dependent upon the data sheet. If you are talking about something a yellow one, supposedly this is the green color dot matrix, this is the yellow color dot matrix circuit diagram over here. These are column arranged. If you are talking about green one, they are row arranged. That's why I've given it green over here, so it's different over there. Now when you are talking about something 1 cross 4 green dot matrix, so this means you are going to have 1 2 3 4 5 6 7 8 rows over here, and then these are going to be combined with the second dot matrix, third one and the fourth one also. Let me use another one, Microsoft OneNote. This is creating a lot. So if you have something 1 cross 4, for 1 cross 4 you will be having this one. So these means that you are having 1 cross 4. So this is the first dot matrix, second dot matrix, third dot matrix and fourth dot matrix. And if you are talking about green dot matrix, this means that it is row wise arranged, 1 2 3 4 5 6 7 8. So you are going to connect 8 transistor pairs over here, and when you are going to talk about the ULN2803, since here they are arranged in 8 columns like this, 8 columns like this, and 8 columns. So for each one of these you are going to have ULN2803 IC. So this is that ULNIC, this is that ULNIC, this is that ULNIC over here. Okay. Now for those who have 75HC595, you are going to have a 75HC595 IC here. You are going to have a 595 IC here. You are going to have a 595 IC here. You are going to have a 595 IC here. Now what this 595 IC will do, you are going to have actually a serial data in from a microcontroller. This is that serial data in, and there will be some clock as well and some associated signals over there, and there will be an output over here. Now this is the same way in which instead of having 8 pins here, 8 pins here, 8 pins here, 8 pins here, you require so much resources from your microcontroller. So what you are going to do, you are going to connect these 8 pins with this IC 75SC595 over here, and you are similarly over here. So what this will happen, you will give serial data over here based on the clock, just like your hard disk in your computer works or your USB device works. That works on a single wire or maybe 2 wires over there in the USB case. So this is going to be serially coming in, data will be arranged over here, then it will be going out from here, then it will be going out from here, and then going in, and then it will be going out and going in. So in this way you are going to give 32 bits of data by just one single wire and one clock pin over here. So in this way, whoever has those who have projects of 75SC595 over here, they are going to have this connection with the 1x4 over there. But those who are going to have supposedly those who are having RGB dot matrix over here, RGB dot matrix means that somehow if you are arrange them in 2x2 over there. What does 2x2 mean? 2x2 means that you are going to have, this is the first one, third one, and fourth one over here. For RGB, they are arranged over here. If I open the data sheet in front of you, they are arranged row wise over here. So what does row wise mean? That your transistor will be here, first transistor pair, second transistor pair, third transistor pair, fourth transistor, fifth, sixth, seventh, eighth, and similarly 9, 10, 11, 12, 13 to 16th over there. So there will be 16 transistor pairs for the RGB, and this first row will be connected with this first row of the second one. Similarly, second over here, third over here, and similarly for the all of them. Now this is the source side from where the actually current is coming in. But wherever you have maximum size, अभी मैं आपको बताता हूँ बेटा, just wait for it. I will just give the limitations as well. Now when you are going to connect this one with the ULN, since this is red, green and blue, so here the problem will actually occur over here, because this one will actually become a large one. This time you are going to have a ULN IC over here, 2 ULN ICs for the red, and then this is the red, and then you have a green one for, this is 2 ULN ICs for the green one, and then certainly the blue one, which is actually going to be again 2 ICs over here for the blue ones over there. And why 2 because these have 1 2 3 4 5 6 7 8 and then 9 10 11 12 13 14 15 16. So similarly, this was the red connection, similarly you will do the green connection, and then you will similarly do, this is the blue connection and this one is the green connection over there, and this one has to be the red. I will understand. 595 IC will be again given to you, data by Sir Bilal, just don't worry on that one. Okay, so this is red, this is green and this is blue. Now one thing very important, when you are connecting these rows, these columns are also going to be connected with over here, the above ones over here. So please combine them over there. Now when you are going to have a 595 IC over here, this is very important. So when you are going to have a 595 IC, you will have 595 IC, 2 595 ICs for this one. Why? Because each 595 IC is going to take serial data in and give you 8 bits output. Again 8 bits output. So these ones are for the red, then the next one 595 IC, this one, and the next one, they are for the green one, and it will be given data from the green pin of your microcontroller. Certainly we will name that one, and similarly the same technique for this one. Now what will be the advantage of this procedure? That instead of providing 16 here, 16 here and 16 here, you are just providing 16-bit data by a red pin and some clock pin over there. Similarly, you are providing 16-bit data over here from this green pin and certainly some clock pin over there. And similarly, you are providing this one by some blue pin or blue serial pin over there and certainly some clock pin. So at the end of the day, the point is it that you are actually making the interface with the controller easy. But yes, what happens over here, when you will see this whole PCB, it will be actually very, very large. Now, as far as the size is concerned, the ideal size is this. Remember, for all projects, ideal size is this, that all of the PCBs should be equal to the size of their dot matrices arranged. What I mean by that, when you're talking about RGB, you know the dimensions of your RGB here. So you know 2 of them, 3 of them and 4 of them. Better if all the circuitry remains inside this area, that is the area in front of the dot matrix. You have the lower one as well, because you are going to place these dot matrices on the top layer as well. So you are going to put female headers over there, so you have ample amount of space for all these ICs over there. Now for 1x4, again you have ample amount of space over here, so you can do it. Try to make them in the same one. Even if you can't make it, we will be having more meetings according to this process over there. But even if you can't make it, just try to make it not lengthwise. Don't increase it. Don't increase it lengthwise. Just increase its width over here. This is very important. Okay. Plus, every resistor that is connected with the ULN, this is very important. Every resistor that is connected with ULN has to be 1210 SMD size, and the resistor that is connected with BC869 SMD transistor, by which I mean this resistor of 10 ohms, this resistance of 10 ohms has to be also 1210 size. This is very important. Don't reduce it. This is very important. Then next thing, all the other resistances, they will be of 0805 size. This is very important. So all the resistors are going to be of 0805 except these two, the resistances which are with the ULN and which are with BC869, they are of 1210 size. Okay, I will do one small calculation if 1210 size is enough. If they are not enough, then I will update it on the MS Teams over there. But up till now, 1210 size, since it can handle a quarter watt easily, so that's why they are enough. But if you require supposedly something half of watt, then I will update this one with some other size over there, and all those sizes are available in LTM. G, how much? Any questions, G? Ramesh Javed, you are always okay. Don't worry about this understanding of the 595. This Sir Bilal will actually take over from here, and he will actually give you the initial understanding over here. Gigi beta, bilkul. You can unmute your mic because I don't have much time. I have to start the other session as well. So please unmute. Anyone who want to ask any questions, please unmute it. I don't know why the sound is still not coming. There has to be some problem in MS Teams. The sound is still not coming from the Ahmad Asim. You can write down in the okay, Mohammad Ammar Akhtar. I hope so. I have given you the right instruction over here. Your question I have answered. Please write it down in the conversation window. I guess voice is not clear over here. In fact, it's not even coming through me. I don't know why. Bilal, can you speak? Bilal, if you are there. RGB, beta, 1x4 RGB means, listen this one again over there. 1x RGB means that you are going to have 4 RGB arranged like this. Okay, ji? You have arranged 4 RGBs like this. Since RGB is controlled row wise, this is 8 of these pairs over here. In fact, I made 9. So these will be 8 pairs, and they will be combined with the next one. This will be combined with the next one. This will be combined with the next one. So they are going to have 8 transistor pairs over here. This is RGB over here, and then it will come to the ULN IC. Here actually this will actually be a lot of ICs over here, because the first thing first, if you are talking about the red color one, ULN, so there will be one ULN here for this one ULN in red for this one ULN for this one, and one ULN for this one. So this means that for 1 cross 4 RGB, you are having 1, 2, 3, 4 ULNs just for 4 are red over here. Then the next ones, if you are talking about, since this is an RGB, so you will require 4 of them for the green one, and then you will require let me use the the blue ones over here. So you will be requiring 4 of them over here for the blue ones. So in total you will be having 12 ULN ICs. This will be hectic, but this is doable, and you just have to arrange the nets and all that stuff over there. So this will be connected with this one green, this will be connected with this one, this will be connected with this one, this will be connected with this one, and similarly for these blue ones over there. Now some have questions, some have asked this question over there. नहीं बेटा, VCC के connections आपने करने हैं. Ahmad Asim, you have to do the VCC connections. It has to be something similar like this one. It has to be a VCC connection, LM7805, capacitor, resistor, all this part has to be a part. No dip switches, only male headers have to be added. No dip switches, only male headers have to be added. ठीक है. 2x2 ग्रीन डॉट मैट्रिक्स में 2 IC और 16 पेयर ट्रांजिस्टर्स के होंगे. जी बिल्कुल हसन बशीर, यस इट विल बी समथिंग लाइक दिस. सर हमने 2x2 YDM में ईच मैट्रिक्स का अलग कनेक्शन करके उनको 2 ऑर्डर में ऑर्गेनाइज करना है. हर एक का अलग अलग कनेक्शन बेटा. जब 2x2 में आप करते हो, प्लीज रिमेंबर when you are having something in 2x2 over there, something like this over there, you are going to combine rows of the first these two, and then you are going to combine rows of these 3 and 4th as well. So ऐसे नहीं करना कि हर एक को अलग अलग करना है and then combine them. You are going to treat them as one matrix. Remember the saying, increasing this one, we are increasing the number of matrix over there. हाँ जी बिल्कुल, they are in 2 layers. These projects have to be done in 2 layers. 595 के ऊपर अभी आपको सर बिलाल, मैं अभी सर बिलाल से कहता हूँ कि वो दोबारा मीटिंग में आ जाएं. आप लोगों की ये मीटिंग कंटिन्यू रहती है, आप लोगों से 595 की सर्किटरी वो डील करेंगे. किसी के कोई क्वेश्चंस हो, आई विल ट्राई टू मेक सम यूट्यूब वीडियो ऑन 595 और आई विल आस्क सर बिलाल टू मेक इट so that we can have an understanding, because 595 IC हमने अभी यूज नहीं की है, but it is simply a serial to parallel converter type or something. No, not on Vero board beta. Ahmad Asim, you don't have to make it on Vero board. This has to be a PCB design. This has to be a PCB design. This is very important. This has to be a PCB design. आपने इतने yellow dot matrix और सब कुछ कर चुके हो, and you have to submit us the designs, but you will have to make it physically also. ठीक है? Project has to be made physically also. Okay. Pictures of what beta? Ahmad Asim, can you pictures of what? This is very important. I don't know. Bilal has actually gone somewhere, or I don't know where he is. Sample project. Okay. I will. In fact, let me just find it out. Maybe I have something with me. Okay, no, I don't have something. This is just the workshop. In fact, last year actually. Maybe I will try with it. Just give me a chat message and I will try to send you some pictures. Okay. Any questions Ji? Apart from 595? Okay, in 2x2 of RGB will we attach the columns of 1 and 3 Yes, of course beta, and 2 and 4, yes beta, बिल्कुल exactly ऐसे ही. ठीक है. If the numbering is the same as I have shown you here, 1 2 3 4. ठीक है. This lecture has been recorded, so you can go through this one. In fact, some of the data was not communicated to you, but I was writing it on my computer and I never knew that it actually went off the connection. Sir Bilal is still not here, so I think so there is some problem with his internet connection or something. So most probably I will ask him to arrange a new session, maybe today, maybe by evening or something, so that 595 is communicated to you. Meanwhile, those who are still interested in actually having the 595 circuitry, these are the two links which can be helpful. Those who have 595, जी बेटा ग्रीन डाटा डॉट मैट्रिक्स की डाटा शीट वेबसाइट पे अवेलेबल, you can, I'm pasting that one as well. But if you are going to buy this green one, when you are going to physically make this project, please have a consult with me that from which shop you are going to buy that green dot matrix, because all the shops don't have the same data sheet. Okay, so this is very important. Okay, so this is very important. So buy this green dot matrix data sheet which I am giving you. Okay, the pins, the size is the same, just like you have used the yellow dot matrix. Okay, apart from 595, any questions over here? I hope this is very clear. Nothing is fancy over here. You just are increasing. You are, up till now you are actually having 8 cross 8 LEDs arranged in a matrix form. Now you are increasing them to 16 cross 16, or you are increasing it from 8 cross 32 or something like that. So this is just an increase in the dot matrix. Just the complexity is increasing. Otherwise, I guess, believe me, when these, especially that 2 cross 2 over here, the 2 cross 2 RGB one, those who are the group, by complexity wise, this is going to be the most difficult project of this, I guess, these 2022 projects over here. So whoever that group is over here, I expect something good from you. So and if you achieve it, one thing very important, since this is just the first project meeting, but if you have made a very good project on hardware side as well, and you have designed it also beautifully, maybe we can supersede all of your marks whatever you have done before, and we can replace them with a very good A plus or A whatever in this course over here. Because the whole thing that is about this lab is actually concentrated in this project, so that you can design it, you can make it on the software, and then you can actually solder it. So if it is working fine and everything is good, then we can award you the maximum highest grade easily. So even if you have not submitted something, or if you have not done something, then maybe this is the last chance for you, so that you can actually make out from this lab. Okay, so I guess Sir Bilal is here. I don't know how he is going to make his voice. I have literally no idea. Bilal, I don't know. I don't know why your voice is not being heard, but this is very important.